Okay, so we just spent a lot of time analyzing the square root of 50 just before. So why would I have it here again? Well, because I want to model for you the way that generally most teachers, me definitely, but most teachers show how to simplify this. Because we don't ordinarily go through all of that theory just to get the square root of 50 to be simplified. Right? I mean, kids would feel tortured by this if we did that. So the way it's usually shown is this. You take the square root of 50, and in your head, you're going to break it out. You're going to say, all right, what was the biggest possible perfect square factor? All right, which of those 4, 9, 16, 25, 36, 49, which one of those numbers was the biggest option that 50 could be split into two factors on? And we said before it was 25. But I don't want you to write 25. I want you to write the square root of 25. All right? Now, some teachers don't care about this. Hold on, let me take a step back. 25 times what? Well, of course, 2. So the square root of 25 times what? The square root of 25 times the square root of 2. I always say put the perfect square first. All right, because that's the one that you're going to simplify, and then that's what's going to wind up being the coefficient of your radical. So what's the square root of 25? Remember, not radical 5, but just straight up normal pretty 5. So 5, and then this is your leftover stuff that has to stay under the radical, right? And that's just 5 radical 2. And to be honest with you, this step right before here, we usually don't even write that. All right, so you split it into the biggest perfect square first, and then whatever the leftover factor that you need to get to 50 is, right? So 25 times what? Radical 25 times what? Radical 2. And that's what goes in the second branched out piece. All right? So that's how you get to that. So with that in mind, let's do it for you. So if I asked you about the square root of 12, all right, so you sit there and you think again. I got 4, 9, I'm skipping 1 because 1 doesn't do anything, right? 4, 9, 16, 25, 36, 49, 64, 81, 100. Now again, those are the ones that you're usually generally going to live by, and you're definitely going to live by them here because I don't have a number bigger than 72. All right, so you're going to probably be from here over. All right, so now you say to yourself, which is the biggest factor in here? 12. Well, first of all, 12 is here, right? So does 9 evenly go into 12? No, it does not. Does 4 evenly divide into 12? Of course it does. So that's your perfect square here. So you're going to put the square root of 4 times the square root of what? The square root of 4 times the square root of what would give you the square root of 12? Well, just like 4 times 3 is 12, radical 4 times radical 3 is radical 12. All right, and then you know the square root of 4. It's 2. So this is 2 radical 3. But if you don't know these perfect squares, you've got no shot. All right, so again, you throw that in the calculator, you throw that in the calculator. They both give you, whatever, a 3-point, blah, 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 and they would match exactly. So you could always know if you got it right. All right, square root of 24. All right, well, 24 is here over. Does 16 evenly divide into 24? It does not. Does 9 evenly divide into 24? It does not. All right, well, I hope 4 does. What if 4 didn't, though? If 4 didn't, then it would just be the square root of 24, and you would leave it. But 4 does evenly divide in. So you would split that into the square root of 4. Well, radical 4 times radical what would give me radical 24? Well, 4 times 6 is 24. So radical 6. All right, and again, I'm putting this number first because that's the one that's going to come out. I know the square root of 4. I just did it in the step before. It's 2, so 2 radical 6. All right, so the square root of 24 simplifies to 2 radical 6. Okay, so 72 and 48 are a little on the tricky ones, but they're good for what we need to be comfortable explaining and you understanding. So when I look at 72, so that's here. All right, 64 doesn't go into 72. 49 doesn't go into 72. But you know what? 4 does. But so does 36. All right, kids are generally pretty, and so does 9. Right? 9 times 8 is 72. 4 times, I'm doing this in my head, I forgot. Goes in evenly. I mean, and 36 goes in evenly. So like you got a bunch of options here that you have to pick from. All right, so you got to be careful. Why am I blanking on 4 times what? 18 maybe? Yeah, probably 4 times 18. So you want to say what's the biggest possible perfect square, right? So if you chose 4 or 9, you'd have to keep simplifying it after that. You don't want to do that. Pick the biggest possible perfect square right away. 36 times what is 72? 2. So radical 36 times radical 2 is radical 72. What's the square root of 36? 6. Again, no radical on that 6, just 6. So 6 radical 2 is your simplified form of radical 72. All right, same concept as before with the 48. Kids usually see that 4 goes into 48 perfectly, but you have to see that 16 does as well. All right, so you want to split this to the biggest possible perfect square. Radical 16. Radical 16 times what is 48? 16 times 3. So rad 16 times rad 3. So rad 16 is regular 4. And you're left with 4 radical 3. All right. I'm going to do 2 more and I'm going to stop. Now, when you look at 5 and 6, they got a coefficient already outside. Now, each one of the examples we just did wound up having a 2 radical 6, a 4 radical 3, a 6 radical... We almost put the coefficient there. Well, now there already is one. Right? So, no big deal. It's already out there. Just kind of ignore it, but follow it down. You break down rad 50, and I'm using 50 again because I know we already did it. We decided before that rad 50 was rad 25 times rad 2. And this 3 is already outside. So, okay, I'll just keep carrying it down. 3 rad 50 means 3 times rad 50, right? So I'll put a little multiplication symbol there. What's the square root of 25 again? 5. Well, that shouldn't look hard. I know what 3 times 5 is. All right, 15. And 15 times radical 2? 15 radical 2. That's it. All right, you can sit there and say, oh, I remember that rad 50 is 5 radical 2. Well, what's 3 times that? That's an outside times outside. 15. All right, same thing here. I know you know the square root of 4, but that doesn't say the square root of 4. That says 4. All right, so 4 comes over. Rad 18 splits. All right, what's the biggest possible perfect square that is divisible into rad 18? 9. So rad 9 times rad 2. What's the square root of 9? 3 times the square root of 2, 4 times 3, 12 radical 2. All right, and that's the kind of examples that show up in a variety of different math classes that I want you to be able to handle. All right, so I'm going to stop there. All right, good luck with the examples, and I'll have that in a CASEL assignment that is assigned and due on Wednesday. All right, have a great day.